So what's the need for BGP here? So the need for BGP comes in multiple forms. The biggest one here is BGP is a protocol we use in internet service providers. And what we're doing with this protocol is not calculating the best path to every destination network using some shortest path first algorithm like we do in EIGRP or OSPF. Now, I realize EIGRP uses the dual algorithm, but effectively it's calculating the shortest path to a destination. BGP, rather, has to be able to implement routing paths between ISPs based on business agreements. So ISP1 and ISP2 here, they have to agree on some policy about how much traffic is going to be exchanged. There's going to be some financial aspects of this. There's going to be some physical layer aspects of these connections, such as how big is the link between ISP 1 and 2? How much does ISP 1 charge ISP 2 for data transferred and vice versa? So when we're setting up BGP, it is an incredibly versatile protocol to allow us to establish policies that mirror the business contracts that exist between the different internet service providers. Now, in an enterprise network, you're not going to need to know the details of how BGP is implemented on the internet. Rather, we're going to need to know how BGP is going to behave in a redundant internet access environment. So let's start with this example here. Here we have Miles master editing over there on the left-hand side, and he's a business and his business is booming. And what he needs to do here is he needs to create a redundant connection to the internet. So he goes over and buys some internet service from TCAP. He's able to put 2 routers in his edge and get that internet service from TCAP there. All right. So what TCAP's ISP is going to provide then is it's going to provide some public IP space. And here we're going to give Miles as master editing 2030.113.88/29. All right, and that's going to let Miles set his web server to have an IP address 2030.113.90. Now, when anybody connects on the internet, they're able to send their traffic. It's going to get routed to TCAP's ISP, and they're able to get to Miles's web server. Should one of those links go down, the router go down, or the link go down, we still have access through TCAP's ISP out to that web server. Now, what we don't have here, though, is we don't have a redundant internet service provider. If TCAP's ISP goes down, our users out on the internet will have no mechanism to get into our web server. Oftentimes, when we have redundant internet access from a single internet service provider, it's rare to have that internet service provider provide redundant paths into our network or into the facility that we're working with. Typically, when we get internet service, the internet service provider runs one single connection into the building. And oftentimes what we'll do then is maybe we want some redundant hardware in our facility so we can put multiple routers in our enterprise network, even though we may only have one physical link to our ISP. So one of the ways we can solve that is we can talk to our ISP and have them run redundant paths into our building, or we can get multiple ISPs. Now, before we move on, let's take a quick look at what happens when an internal user inside of Miles's master editing wants to use the internet. We're able to use either connections here, and if one of those network connections goes down, one of those routers breaks, we still have a path into our internet service provider here. So we have redundant paths here from inbound traffic from the internet into our network and outbound traffic here.